Microstate you can calculate using formula. So this formula it is calculated from number of orbitals and electrons present in it using this formula. N factorial upon R factorial into N minus R bracket over factorial, where N is nothing but N is equal to twice the number of orbital, twice the number of orbitals. If you having s orbital, then you can take a value of n is 2. If you having p orbital, then value of n is p orbital is 3 in number, so you can take value of n is 6. And if you having d orbital, then value of n is you can take 10. For f orbital, it is for s orbital you can have n is equal to 2, p orbital 6. Is it this screen is visible?
No, sir. Yes.
Now?
No, sir. Yes.
Now it is okay, fine. So see if p is there, then number of, you can say for
6.
it is value of n is 6. For d orbital, it is 10. For f orbital, it is 2, 6, 10, and 14. So this is the way you can see write down the value of n. Now, after that, then you can have a, after writing this value of n, then r. What is r? So r is the number of electron
Number
which
of
is
electrons.
present. Yes, it is present in that orbital. So r is called number of electrons. Number of electrons present in it. So you can calculate the particular number of microstates. For example, if you want to calculate for this p2 orbital, small p2, p orbital is there, okay? How to getting number of microstate? So here n is equal to, you can take 6, r is equal to 2. So number of microstate is equal to 6 factorial upon 2 factorial into 6 minus 2 factorial. 6 factorial is nothing but 6 into 5 into
50.
4. In this way you can go, okay? Into 3 into 2 into 1 continue, but we stop here. Yes, here it is 2 into what? And 4 minus 6, 6 minus 2, that is 4 factorial. So 4 factorial gets cancelled. 30 by 2, that is called 15. So these are the number of microstate. What's about for D2? Number of microstate is equal to 10 factorial upon 2 factorial into 10 minus 2, that is 8 factorial. So it's 10 minus 9 into 8 factorial upon 2 into 1 into 8 factorial, it is 45. Good. So in this way, you can calculate different type of number of microstate. Suppose you can have a f orbital, so you can take in this way. But see, suppose sometimes what happens, you may have a S1 P1, one electron in both the orbitals. So at that time, you do the multiplication of the number of microstate of both. So total microstate is equal to first for s orbital, that is 2 factorial upon 2 factorial into, sorry, 2 factorial upon 1 factorial into into 2 minus 1. That is again 1 factorial. This is for s, and for p orbital it's a 6 factorial upon 1 electron is there. So 1 factorial and 6 minus 1, that is 5 factorial. So you can have a 2 factorial upon 1 factorial, that is 2 into 6 factorial upon 5. So it's a 6 into 5 factorial. 5 factorial gets cancelled out. So it's a, what is your answer? Number of microstate is equal to 12. It is a 12. So this is the one formula to calculate microstate. Second formula is to calculate microstate from ground term. This is from orbital. Okay. Now the second way to calculate number of microstate, it is from ground term. So you can have a say number of microstate from ground term. That is from term symbol. So formula is number of
Sir,
microstate is equal to
in
it.
the sir, in the
Yeah,
previous one, what is the value of R? The number of unpaired electron or number of total electrons?
number of total electron presence in given orbital. अनपेड है पेयर है वो तो इलेक्ट्रॉनिक कॉन्फ़िगरेशन तो आपको दिए ही नहीं है.
नहीं नहीं उसीलिए पूछा. अगर
आपको
D6 और D7 होगा तो
see microstate is a possible arrangement way to arrange the electron in a possible way. So ये जो है ना टोटल इलेक्ट्रॉन्स है, क्योंकि P2 P3 या तो मैं आपको P4 प्रोवाइड करता हूँ. So that means it is you can have a see total number of simply P, it is nothing but
How
so you
many
can have a,
probabilities that can
it
electron
is a
reside in orbital?
probability, yes. So you can have a suppose P4, so we don't know, it may be high spin or low spin, whether pairing is take place
Because
or
of
not.
this, we are using factorial.
Yes, so we simply go for probability factor. So P4 है तो वो कितने different ways पे अरेंज कर सकते हैं. So number of microstate इस केस में अगर आपको कैलकुलेट करना है कैसे करेंगे? Simple, see it's a you can have a here 4 fact sorry d p orbital is total p orbital is 3 in number. So you can have a here 6 factorial. Here it's a 6 factorial into what you can do. Number of electrons are 4, so it's a 4 factorial into 6 minus 4 factorial. So it's a 6 into 5 into 4 factorial divided by it's a 4 factorial, and 6 minus 5 it's a 2 factorial. So you can have a 6 into 5, 4 factorial gets cancel out. So it is, what is your answer?
okay sir.
15. Okay. Same way you can have a CF3 configuration is there. So for F orbital, you can take n is equal to 14 because f orbital is 7 in number. So you can take 14 factorial upon 3 factorial into 14 minus 3 in this way. So 14 into 13 into 12 into 11 factorial. Here it is 3 factorial, that means 3 into 2 into 1, and 14 minus 13, that is 11 factorial. 11 factorial gets cancel out. 3 into 2 6, so 6 2 ja, so it's a 14 into 13 into 2. Okay, so 26 into 14, so you can have a answer. I am say directly write down the answer of that given. So you can have it's a 14 into 13 into 2, that is 364. Now see, number of microstate with ground term is given, so at that time you can go for this formula that is called 2s plus 1
12 plus 1.
into 2l plus 1, yes. Where s is a spin quantum number, l is a, you can say, l is nothing but it is a
Angular momentum.
total angular momentum quantum number, or you may have a see this formula, or you can have a number of microstate is equal to two j plus 1. J is called total quantum number. So how this formula is utilized? Suppose you are given this one P32 term. So what is J value?
T.
This is our term
J,
symbol.
yes, 2. 2. J.
It's a 2, yes. This is a term symbol. This is a ground term. So J value is a 2. So you can have a how many microstate are possible?
5.
That is 5. Or you can have a, you can go for ground term, especially if you are not given J value, but you are simply given 3p. Then in this case, J value is not there. So what you can do? You can calculate L and S value.
LNS.
Okay,
Then
so how to
we
getting
will
L
put
and
this
S?
in the period formula.
So say 2s plus 1 value is already given. That is 3 multiplicity. For p orbital, L value is 1. So what is 2l plus 1 value? It is also 3. So total microstate is equal to that is 9. Okay, 2s plus 1 and 2l plus 1 to go on that way. So total microstate can be calculated. क्या
सर ये 2j plus 1 equals 5 कैसे आया?
J वैल्यू कितनी है यहाँ पे?
यस सर 2 and j की ओके हाँ सर
तो यहाँ पे सिंपली 2 डाल दिया मैंने. से आपको ऐसे आपको चेक करना है टर्म सिंबल कैसे प्रोवाइड करते हैं. जो अगर टर्म ग्राउंड टर्म है आपको ऐसे प्रोवाइड करेंगे. सी ground term is given in this way. For example, if you given the ground term with this way. Suppose you are given ground term this way, 2s plus 1, चल इतना ही दिया है ग्राउंड टर्म में, तो आपको ये फॉर्मूला यूज करना है। एक ये पॉसिबिलिटी, सेकंड पॉसिबिलिटी ये है, यू आर गिवन फुल ग्राउंड टर्म। Okay, so in this case you can use this formula, total number of microstate is equal to कौन सी फॉर्मूला यूज करोगे, 2s plus 1 into 2l plus 1,
Sir.
and here it is total microstate is equal to,
Sir, 2j plus
1.
yes, suppose you are given 3f4, what is total microstate?
9.
It's a 9. It is very simple
9.
job. 4 2 into 4, 2j plus 1, that is 9. Good. What's about 3f2?
5.
It's a 5. Total microstate is equal to 2 into 2 plus 1, that is 5. But if you are given this type of term 4D, how to getting total microstate?
12 plus 1 and 2s plus 1.
So here see 2s plus 1 value is,
4.
what is L value for D term?
2.
2. So 2L plus 1 value. So here you can have a C 2s plus 1 into 2L plus 1.
20. 20.
That is 4 into 2L plus 1. That is 5. That is 20. Okay, so in this way you can calculate number of microstate. Suppose term is 2F. How to getting number of microstate? So 2s plus 1 value become 2. 2L plus 1.
14.
L value for F orbital is?
3.
So it's a 7. So total microstate are 14. Good. Is it clear up to here?
Yes, sir.
Okay, fine. So see, this is a very useful, and see, using this formula to calculate microstate. So if orbital is given, then there is a different method, and if orbital may not be given, then there is a this method. Sometimes what happens, you may given configuration like this way. So this is simply represent excited state. एक्साइटेड स्टेट में ऐसा कन्फिगरेशन होगा कि एक ऑर्बिटल में से इलेक्ट्रॉन अपर लेवल पे माइग्रेट करेगा, तो उस टाइम भी आप मल्टीप्लिकेशन करके फाइंड आउट कर सकते हो। सो दिस इज द वे यू कैन हैव ए डिफरेंट microstate. नाउ आफ्टर दैट, then you can have a you can also calculate magnetic moment, but that we will take later on. Term symbol we have completed. Now we go for the different splitting of term into different level, or we can will go for especially energy comparison. which orbital having higher energy or which one having lower energy. So what are the ways where you can predict the energy, how it is predict? So for that, what you can do, in order to getting energy, you can go for checking its J value. You can go for checking its L value. For lowest energy term, the first of all, in all the case, we will going to see the highest spin multiplicity. If spin multiplicity is similar, then we go for highest value of L. So in order to compare energy of ground term, that is the lowest energy term. So for lowest energy term, symbol, first of all we see the highest value of for lowest energy term symbol. First we see, yes, first we see highest multiplicity. See the term with highest spin multiplicity. पहले आपको स्पिन मल्टीप्लिसिटी देखना है. If two terms with same multiplicity, then you go for the term with highest L value. Is the lowest energy term. Okay, so this is the rules to calculate which one is act as a ground term and which one is act as a, you can say, in which case this is act as a higher energy term or which one is a ground state term. So the question is like identify the ground term in following. First is you are given P1, you may given P3, F3 and G1. Which one is a ground term?
3F.
So first you go for which one? 3F, yes.
3F.
3F, sir, 3F.
So your answer become 3F because first you look at the L value. So the spin multiplicity. So these two term having triplet, so it is having higher energy. Now these two having same multiplicity, then you go for checking L value. So F having higher L value, so it is your ground term. What's about out of this triplet P, triplet D, triplet H, then singlet I, Which one is the ground term?
3H.
The answer become triplet H. Yes. Or you may have as sextet S, quadrat P, quadrat G, and doublet I. Now tell me the ground term.
6S.
6s.
Yes. So you always look at the multiplicity first. If multiplicity is similar, then you can go for checking its L value.
सर आई का 3i का नहीं जाते होगा सर 3h से
नहीं, I में मल्टीप्लिसिटी 2 है ना. आप मल्टीप्लिसिटी देख लो पहले. I में कितना मल्टीप्लिसिटी है? पहले कौन सी?
सेकंड वाले में सेकंड वाले में
सेकंड में I में मल्टीप्लिसिटी 1 है.
अच्छा सर मेरा का 3 है वो
नहीं, 3 नहीं है, 1 है. सिंगलेट है. So see, this is the way which you are getting, you can say different. Now see, आपको अरेंज करना है तो कैसे करेंगे? चलो एक भी लेते हैं. 3F है, 3P, then you can have a 1D and 1S, singlet S and singlet G. इसको आपको अरेंज करना है according to decreasing order of energy, or you can say increasing order or decreasing order of energy. चलो पहले कौन सा आएगा?
3f.
सो ट्रिपलेट वाले दोनों है वो. इसमें 3
Then 3p.
ट्रिपलेट F is comes first.
Then e.
ये हाईएस्ट एनर्जी है, लोवेस्ट?
Highest.
ये तो लोएस्ट है ना.
लोवेस्ट है. हमने
Lowest
वो
से
ग्राउंड
highest.
टर्म देखा था ना.
Lowest to
टर्म
highest.
यहाँ
Lowest to
डिक्रीजिंग ऑर्डर
highest.
लिखना है. पहले कौन आएगा सबसे कम? सो बेटर है कि आप उसको, चलो पहले आप ऐसा करो, जो इंक्रीजिंग ऑर्डर है वो लिख दो, उसके बाद आप रिवर्स कर देना. ओके. सो व्हाट इज योर इंक्रीजिंग ऑर्डर?
3F, then
3F.
3P.
यस, इट्स 3F, then 3P, then
सर लास्ट वाला क्या है? 1J.
लास्ट वाला 1G, सिंगलेट G टर्म.
1G, then
to
1D, and at last 1S.
So 1G, yes. Then 1D,
1s.
and last one is 1S. So what is decreasing order? You can starting it from 1S. This is actually increasing order, so this term may not becomes here. So this is this order which we have written, it is increasing. That means you can show greater than less than sign. 3F is less than 3P. So this is the order. Now see, so this one having higher energy. Next is 1D, 1G, triplet P, triplet F. This is a decreasing order. Okay, is it clear?
Yes, sir.
Okay. Then you can see from the ground term, you can also calculate magnetic moment. How it is possible? So magnetic moment of the especially lengthenite, उसकी बात करते हैं.
स्पिन कंट्रीब्यूशन भी आएगा और एन ऑर्बिटल कंट्रीब्यूशन भी
यस,
आएगा।
इसमें दोनों आएगा। सो म्यू टोटल इज इक्वल टू, दोनों आएगा, म्यू स्पिन ओनली एंड म्यू ऑर्बिटल। सो यू विल गेट टोटल, एंड इनके लिए एक फॉर्मूला भी है, सी टोटल इज इक्वल टू जी लेंथ स्प्लिटिंग फैक्टर अंडर रूट J is a total magnetic quantum number A plus 1. Okay, so these are the two formula. Here J is, what is G? G is equal to, it's a length factor so how to getting, how you can calculate G? So G is calculated using this formula, 1 plus J into
Yes.
J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2J into J plus 1. Here 1 is written here. We have not taken LCM. So in this way. Okay. Or you may have a, by taking LCM, you can have a formula. You can multiply with 2J plus 1. So you will get this formula also. 2J plus 1. 2J into J plus 1. Plus J into J plus 1. Plus S into S plus 1. Minus L into L plus 1. Divided by, you can have a, you can also use this formula for calculation of G. Or again you can simplify this one. So you may got G is equal to 3J plus 1, J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2J into J plus 1. Okay. So here see, you can simplify again this formula in this way if you want to simplify. J into J plus 1 divided by 2J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2J into J plus 1. So here see this term is cancelled out. So it's a 3 by 2 plus S into S plus 1 minus L into L plus 1 divided by 2J into J plus 1. So this is one of the simple formula to calculate G value. Okay, we are using this formula. Okay. Is it okay? And see,
Yes,
this
sir.
is we are using only for lengthenide. Lengthenide element is concerned. So this is the formula which we are using. So now suppose if you having F1 configuration. So for F1, S value is F1, S value is
Half.
yes, it is half. What's about L value? It is 3.
3.
So possible J value are, what is the formula? How many values are possible? Possible J value is calculated using 2s plus 1 or 2l plus 1. Here S is less than L.
It minus L minus S.
So it is simply by नहीं वो that is वो तो है बट पहले फर्स्ट लेक्चर में ये चीज बताया था ना आपको वैलिड J वैल्यू के लिए यहाँ पे देखो total J possible is equal to either 2l plus 1 or 2s plus 1. These two formula are there है ना तो depending on condition
Yes.
L greater है तो उस केस में 2s plus 1 जो छोटा है वो लगे है ना
Yes.
इस तरह यहाँ पे कौन सी वैल्यू आएगी
2s plus 1.
yes so J possible is equal to that is 2. So which are these two value? One is 3 plus 1 by 2 that is 7 by 2
And 5 by 2.
and another one is 5 by 2. Two values are possible. Now how to getting G? So G is equal to 3 by 2 plus formula is 2s plus 1. It is 1 by 2, 1 by 2 plus 1 plus 2l plus 1. L value is 3. 12 into L plus 1 divided by J into J plus 1. J value is you can use 5 by 2 for less than uphill. So it is 2 J into J plus, this is a 5 by 2, 2J into J plus 1. So when you solve it, it's a 3 by 2 plus this is a 3 by 4, 1 by 2 into 1 by 2, 1 plus 1 by 2 that is 3 by 4, 3 into 3, 3 plus 1 4, 4 into 3, 12, it's a minus sign here. It's a 12 divided by 2 to cancel out 5 and 5 by 2 that is 7 by 2 so 5 into 7 by 2. Okay, so this is the way to getting G value. Now then you can simply solve it, so you will get particular exit value whatever is there, so you can complete it at your convenience. So see, this is the way you can calculate G value. If you want to write down exact answer, then what is it? 3 by 2 is a 1.5. 1.5 plus 3 by 4 minus 12. That is 3 by 4. What is value of 3 by 4? It's a 0.75 minus 12. So this become minus 11.25 divided by 5 into 7 by 2, that is 3.5. 3.5 into 5, 17.5. So the answer become 11.25 divided by 17.5. So it become minus 0.64. Is equal to 0.8571. Okay. In this way you can do the calculation. But see, it's a very easy when you having L value is 0. What happens when L value is 0? L is equal to 0. So you know very well 2j plus 1 equal to what?
Then only the spin contribution will be contributed.
Yes, J is equal to L plus S. Okay. It is simply equal to L value is 0. So it is equal to S. So you can have a see this formula. G is equal to 3 by 2 plus S into S plus 1. L value is 0. So no need to write down that term. Divided by 2j into j plus 1, where you can replace j by s. So 2s into s plus 1. So it is cancel out. S into s plus 1 is this cancel out. So it is simply 3 by 2 plus 1 by 2, yes. So it is 4 by 2, that is 2. This is for a free electron where you can have a zero angular momentum. That means free electron value of Lind's splitting factor is 2. So you can use only, and mu total equal to, so in this case mu total is equal to mu spin only, because mu L value is 0. So what is mu total? Mu total is equal to G is already we have taken 2. So it's S into S plus 1. Okay. So this is the formula. So you can have a see mu spin only is equal to, if angular momentum contribution is not there, then 2 you can multiply, or you can write down 2 in the bracket. So it become, you can have a 4s into s plus 1. 4s into s plus 1. So we know very well 2s is equal to n. So this maybe you can write down 2s into 2, you can write down inside the bracket 2s plus 2. Multiply 2 in all the two term. So it's n into n plus 2. Okay. So you will get n is equal to 2s. So you will get formula for spin only magnetic moment. Is it clear?
Yes, sir.
Okay. So see, from this atomic spectra is now you can have a atomic spectra where you can having selection rule. You can check whether which spectra is allowed or which one is not allowed. So first selection rule is
Laporte selection rule.
yes, selection rule is Laporte and spin selection. So for that, see delta n, you can take anything. This will use anything. Second one is the Laporte selection rule. What is allowed value?
Delta L equal to plus minus 1.
Delta L is equal to plus or minus 1. Good. So you can have a S2P transition is there. So what is L value? Or P to D, or it may be D to F. So L value is here 0, 1, 2, 3. So see here you can have a delta L is plus 1. So these are the allowed. S2P is allowed, okay?
Yes, sir.
What's about S2D?
Not S2.
Or you can have
Not
a
allowed.
P to
Not
D,
allowed.
P to F, S to F. These all are forbidden. Why they are not allowed?
Because they are not plus minus 1.
Yes, delta L in the first case is 2. 0 to 2, that is delta L value is 2. Here P1 and F is 3, that again 2. S and F, that is 3. Okay, so delta L value is not plus or minus 1. In short, delta L is not equal to 1. Plus or minus 1, and that's why they are forbidden. So this is called particular selection rule. Sometimes see symmetry is mentioned. It may be Girard, it may be un-Girard. Okay, that type of the symmetry is mentioned. So for
G to
that,
U allowed.
you can, yes, you can have a transition from G to U is allowed. G to U, or you can have a U to G is allowed. And Girard to Girard,
Not allowed. Forbidden.
or un-Girard to un-Girard is not allowed. So this is not allowed. DD transitions are what type of transitions according to Laporte rule? DD transitions.
Forbidden transition.
Yes, because L value is 0, so DD
0.
transitions are forbidden. Especially Laporte forbidden.
सर जिराड टू अनजिराड तो क्वेश्चन में बताएगा ना कि मतलब सर हमें कैसे पता चलेगा जिराड टू जिराड हो रहा है या
वो
जिराड
तो
टू
देंगे ना, सिमेट्री देंगे ना। सपोज मैं आपको ऐसे बता दूं कि चलो ये टर्म है 1G 2T1U, तो ये जीराड टू अनजीराड हो गया ना, होगा इसी तरह। वो तो इलेक्ट्रॉनिक ट्रांजिशन है, स्पेशल डायटोमिक मॉलिक्यूल के लिए, उसमें ही आएगा, वो भी देखेंगे। बट आपको पता ऑटोमेटिकली चल जाएगा कि इसमें से वो मेंशन किया होगा सिमेट्री, तो वो देख के बताना है। ओके, ट्रांजिशन इज गिवन, आपको सिलेक्शन रूल अप्लाई करके चेक करना है वेदर इट इज allowed or not. So this is called, you can say, Laporte selection rule.
फर्स्ट
What's
में आपने लिखा था n इज इक्वल टू एनीथिंग, मतलब n की वैल्यू 3 हो 4 हो या 5 हो, उससे कोई मतलब नहीं है, यही हुआ।
उससे कोई मतलब नहीं, इसलिए डेल्टा एन जो चेंज होता है वो एनीथिंग लिख दिया। बट आपको ये चीज, दो चीज देखना है, एस वैल्यू एंड एल वैल्यू। ओके, Now we go for spin selection rule. What happens in spin selection rule?
Delta is equal
Electronic
to 0.
transition take place between the energy level having same multiplicity, then 2s plus 1 will be same. So see, according to spin selection rule, delta S is equal to 0. That is required. This is allowed. And delta S is not equal to 0 is not allowed. Electronic transition take place in between energy level having same multiplicity. Energy level having same multiplicity. Okay. So that means your transition is from singlet to singlet is allowed. Or you can say singlet triplet to
Unallowed. Forbidden.
triplet to triplet. This is allowed.
Allowed.
But what's about transition from singlet to triplet?
Forbidden.
Triplet, or you can say doublet to triplet. These are the forbidden. So these are the third selection rule. Now the fourth one is delta J is equal to either 0 or plus or minus 1 is allowed. And fifth one is mj value become 0 or plus or minus 1. So this is different selection rule. Sixth one is of course symmetry selection rule. Symmetry selection rule. That is from sigma to sigma star, or you can say pi to pi star are allowed. ये
Allowed.
photochemistry में आपने देखा होगा. But sigma to pi star, or you can have a pi to sigma star, or non-bonding to pi star, or non-bonding to sigma star are not allowed. Are not allowed. Okay, is it clear up to here?
Yes, sir.
Okay, fine. Now see in next lecture, we will see exactly what type of we will take certain examples to make practice of all these rules. And then we move to the orgel diagram in this chapter.
Sir, evening में कब होगा?
So today in the evening,